Morning, everyone. We're going to get started in just a second here. We're going to be speaking about continuous delivery and MLOps. So yeah, it will be kind of a fun presentation. I'm pretty excited for this one. We're going to be talking about everything about real world MLOps, really focused on the different pieces of the MLOps platform, from data to training, deployment, monitoring, how it all comes together, and some workflows that come around it that really get that continuous delivery working. The other thing I'll end on is how to measure MLOps platform success. So I'm Simba, I'm the creator of Feature Form. I started my career as a software engineer before running a team of data scientists building personalization, predicting subscriptions, predicting churn over about 100 million monthly active users. At that time, we had to build our MLOps platform from scratch. This is kind of before the days of MLOps really even being a term in its own right. And so a lot of the stuff we did, we had to figure out from scratch. But the benefit of that is that a lot of the things that we built specifically to solve our own problems. Since there weren't many vendors at that time, we kind of had to learn how to do things ourselves. So let's talk a bit about why continuous delivery in MLOps is so important. By first showing the kind of fallacy that we all learn when we first start learning about machine learning. When we first start taking classes on ML, we are given this perfect data set that we then train some model on. It could be like a linear regression or something. And we set up basic loss function and some other hyperparameters, and then train. And that's all. And it always seems to work. The data always seems to be really clean. And that's typically where we leave off. We don't really talk much when we're learning about ML, about the iterative process of we don't really talk much about deploying models. We don't talk a lot about testing beyond just checking loss. And these things become really, really important because in reality, things are much messier. You're dealing with multiple people, you're dealing with a lot of complicated data infrastructure and ML infrastructure. You're going to be working across many different models. You'll run many different experiments. You'll have many different data sets. The whole feature engineering process itself is such a long, expensive part of the process alone. So all this comes together to create kind of a wild, wild west of getting models in production. And as an MLOps practitioner, as an ML engineer, it's our job to get this under control, to make it possible to safely deploy models, do it iteratively, so that we can continue to improve what we're building. Do it in a way that's highly collaborative, so that everyone can learn and teach and make sure that we're getting compounding value in the organization. And finally, for risk reduction. With a lot of the models, we're dealing with highly sensitive data, or we're dealing in situations where it can't really go that. Like if you're building a recommender system, you really have to make sure it doesn't recommend things that are awful or way just off character because it will have a horrible effect on user behavior. So we need something around this, and that's why MLOps was originally created. MLOps is a set of tools and practices to automate and streamline the ML lifecycle from ideation to production. So we should define that model lifecycle first. What is the model lifecycle look like from ideation to production? By the way, before I go on, I should add, if you have any questions, feel free to throw them in the Q&A if you're in the Zoom. If you're on LinkedIn or Twitter, you can just leave a comment and we will be checking those as well. Yeah, and I'll stop to answer questions at different times. But let's keep going. I break down the ML model lifecycle into four distinct stages. There's the data stage, the model experimentation stage, the deployment stage, and then the monitoring stage. Those are the four stages. Now, I have a line on top that kind of seems to imply that it's linear, like you go from one to the other. In practice, you kind of jump between them. But as a data scientist or an ML engineer, the data part, the model training part, the model deployment part, and the model monitoring part typically have four separate tool sets. Um, and they just are four separate problems. Like the way you think about them, the problems that arise, and the solutions look different. So I like to break them down in that way. Um, I'm gonna talk about each of them. So the data stage is the first stage. The data stage is kind of the heart and core of a lot of the ML lifecycle. We take our data, and in the data science portion, a lot of what we're doing is taking that data and analyzing it, understanding it, coming up with hypotheses, testing hypotheses, trying to find signal in the noise that we can then kind of engineer into features that we can then train our models with. This process is also really complicated when you think about how different data is in experimentation, where you typically have either a sample of data or you're at least interacting with a data set that's relatively static, versus in production. In production, we might worry about streaming data. We might worry about scheduling. We worry about feature drift. So the data piece is a very large component of the ML lifecycle and probably the messiest one, in my opinion. Model experimentation and training, this is where we actually train models, where we tune hyperparameters, and also where our model store lives. So this is kind of that stage of in an offline setting, building models. Deployment and serving is now getting these models and the data pipelines into a production setting. So taking it from the model store, putting it into something else that actually deploys it in production. And then finally, we have monitoring and evaluation. Once something is in production, our job's not over. We need to monitor it, understand how it's performing, evaluate its performance. We can use that to kind of build that flywheel so we can continue to iterate and improve the model. It can also be used as well for different types of events, like it can trigger an alert if something's going wrong, or it can trigger a retrain, amongst other things. One thing at Featureform we kind of came up with is taking these ML lifecycle stages and crossing them with these level of abstractions from hardware up to platform. You end up with this grid. And in my opinion, this grid is one of the cleanest ways to break down an MLOps platform. I've seen it done in different ways, but I've always kind of been partial to this grid. Obviously, it abstracts away a bit, as every abstraction will. It's not perfect, but I think it really cleanly captures the different problems to be solved and captures the different tool sets that you'll need to do production grade machine learning. So let's start with the first layer, 0 and 1. Now, this isn't going to be super, it's going to affect how you do continuous delivery for ML. But it's kind of out of scope. But just so I can kind of fill in the picture for you, this is where you would choose your cloud platform. You would choose if you're using Kubernetes or not. You choose kind of the core non-ML infra that everything else is built upon. This is important because it will also potentially limit the tools you can use. For example, if you're using Kubernetes, you want to use tooling above it that is Kubernetes aware and Kubernetes native. Otherwise, you're going to have to build that yourself. If you're using a serverless product, then you need to make sure that your frameworks can handle that. If they can't, then they don't mesh well. So all the layers are very distinct in the problems that they solve, but the lower layers by design kind of power the upper layers. So there needs to be some level of compatibility there. The layers I'm mostly going to focus on here are 2 and 3. These are the ones that are also striated based on those ML lifecycle parts I talked about, from the data piece to the model experimentation, deployment, and monitoring. Now, you may notice, or you may ask, why are there 2 layers? Why and what's the 2 layers in something like data or model experimentation and training? Um, and the way I think about it is that MLOps problems fall into 2 categories. There are the engine problems, and there are the workflow problems. The engine problems are the underlying infrastructure. They're the things that actually compute features, that actually train the model, that actually run the deployed model, that capture our monitoring logs and evaluation logs. So it's the engine underneath. The other problem to be solved are workflow problems, which are much more about, they're workflow oriented. So they're actually much more about how a data scientist or ML engineer works. This is things like where you will have your metadata storage, your versioning, your automation, your triggers. They pretty much orchestrate and act almost like the metadata that kind of power the engine. So they're kind of the framework above the engine. And you'll find that for each of these, I'll go through each vertical one, but each vertical one has an engine and a orchestrator. I'll talk about each of these to break these down. I'll also talk about how this affects CI/CD and continuous delivery. We'll start with data. So there's 2 layers here. There's the, like I said, the engine layer and then the workflow layer. Now, the engine layer is things like Spark, Redis, Kafka, whatever data infrastructure that you use to build and store features. That's the layer 2. Above it is the layer 3. In this vertical, those tend to be things like feature stores. Feature Farm we actually call ourselves a virtual feature store in that we entirely focus on the workflow on top of your data infrastructure to do things like versioning, analysis, getting feature pipelines productions, monitoring, lineage, sharing, reuse, collaboration, and governance. The engine problem that feature stores typically don't solve, at least Feature Farm doesn't aim to solve, are problems like how to serve data in under X milliseconds. Like if you need Redis or Dynamo and need to get it to serve under a certain time period, processing however much data and dealing with streaming data. The engine is what kind of powers that for you. But the thing that makes it all work together as one cohesive component for a data scientist is the feature store. Now, it kind of tracks that, okay, like when I'll get into the kind of the experimentation phase. In the experimentation phase, you will be working with the feature framework to build your features, understand them, analyze them, etc. In this time, you will be creating different versions of things. You'll have a lineage for everything. You'll be able to share and reuse things. Finally, you may find times that you need to actually train models on these things or actually get these features in production. And the feature store facilitates getting those things into production. So the feature store is kind of the solution to getting your data pipelines from experimentation stage into production. And a good feature store will actually unify both of those things. They will work both in the experimentation stage and in the deployment stage. This is the thing that you'll find with all this stuff around CI/CD with ML is that the experimentation phase is unique. It's distinct from production. And it looks different than how software engineering looks because there's a lot of focus on using notebooks. There's a lot it's a science more than it is an engineering practice. And because of that, there's a lot of things that get thrown away. So the difference between kind of experimentation and production are quite different. Now to jump to production, one piece of it is testing. Just making sure that you have proper tests that you can confidently trust, which will allow you to kind of cleanly continue to deploy your data pipelines. They look like there's two different ways to do this. There's many, but these are two very really common. One is data quality checks with things like red expectations. This is where you build your features and then you run these specialized queries to test that the characteristics you expect are true. For example, you might check that a column is unique, or you may check that a value falls within a range. On the data quality check side, you do that on some schedule typically. Maybe at deployment time, you run a query and check those things. The other approach is using data contracts. The difference between doing data quality check and data contracts is data contracts are applied across the data pipeline to make sure that at every stage that your expectations, your guarantees are enforced. So great expectations and data quality checks, your data in your data lake or in your feature store might not match your expectations. And then it will tell you that. And then you can go figure out why and fix it. With data contracts, that's actually impossible to happen. You could never end up in a position where there's something in your feature store that is not in range because the data contract will have enforced it. The problem there is complexity. Data contracts are typically much more complicated and you have to apply them to every stage of the data pipeline. It might be even harder if you're interacting with data engineering team but doesn't use them because you, at some point, you kind of need to apply across the whole stack. So that's the CI part. Now, the CD part is moving the data transformations from notebook into production form. This is going to be really dependent on your tool set. For example, some companies use Java pipelines on like Flink for production and then use Python or SQL or something in experimentation. In those situations, you have to essentially rewrite your features for production. And I see a lot of people who do that. I don't recommend it. The approach that we take at Featureform is make everything either SQL or Pythonic and make it so that in experimentation, it's very easy to run data frame transformations, run SQL transformations. And then for production, you can add proper governance, monitoring, scheduling, and other metadata that you would need to make it a production grade system. And then Featureform will apply all that stuff. So that's what makes it easy to get your data transformations outside of your notebook to production. The trick for the data part of CD, of MLOps CD, is making sure that your data transformations in training and production are as close together as possible, while also making sure that they are simple for experimentation. You don't want to slow down experimentation by making everyone write production grade pipelines when most of that's going to get thrown away anyway. But at the same time, it has to be like a watered down version of the production thing. It can't be completely different or you're just adding more friction and potentially adding more problems. So that's the data piece. Next, we'll talk about model experimentation and training. It's also broken down to two sections. There's the workflow problem and the training problem. The engine problem solves the actual training. It will distribute your training. It might do some form of hyperparameter optimization. And then there's a workflow problem. The workflow problem is experiment tracking, keeping track of every run you do, what the hyperparameters were, what it was trained on, how it performed, any metrics are associated with it, having all that stuff tracked. Also, having a storage for your models, because experiments may create model artifacts. And having those tracked as well, being able to tie your model artifact to the experiment that created it so you can recreate any model, at least be able to see the lineage for models becomes crucial. And then the ability to compare and contrast experiments to be able to kind of come up with the best solution or the best model. This is a little thing I cut from a person called Ari Mas, who's the CPO at Neptune, which I liked. It kind of shows experimentation stage where you're working typically in a notebook. You are doing all of your feature engineering, your training, your evaluation and validation in the experimentation stage. If you look at the top, there's that 4 line that kind of curves, and it points like Spark or Dask, which is where you're actually training. That's essentially the engine. That's where your actual model training happens. And then if you see, there's the number 8, which is the experiment tracking system. And Neptune is one of the many companies that compete there, ML flows and other. But that becomes a crucial part of tying together production and experimentation for the model piece. The experimentation workflow is very notebook oriented. It generates some useful work in a lot of the failed experiments, and it needs something like an experiment tracker and a training engine to power it. Once you have these models in something like a model store, now we need to talk about getting those models into production. Now, I've talked about getting the data pipelines in production. That's done kind of separately. Then you'll have your features ready in a feature store to be able to use in production. But the next step is actually getting the models into production. Now, this can be done quite simply, right? You could just Dockerize a model, just throw up a few containers running the model, point at the feature store, call it a day. But in practice, you're going to want to get much more sophisticated than that. There's 2 problems here. One is the engine problem, which is actually how do I containerize a model? Some models are small enough where it could be just as simple as just putting in a Docker container. But if you're dealing with something like maybe like a large language model, you need to start thinking about GPUs. You might need to actually have the serving container run across different containers. You might have different services working together to actually be the model. You need to worry about uptime. You need to worry about latency. So there's the first problem where there's a lot of kind of MLOps tools, which are all about packaging up a model and making it a deployable thing. Above that, there's a workflow problem. Because just being able to deploy the model is great. But if you want to have true continuous delivery CI/CD, you also need to have a workflow to be able to do A/B tests. You want to be able to upgrade models, downgrade models, potentially with 0 downtime. You want to be able to test things. There are ideas like canary deployments, where you deploy just to a small subset of users first, and you monitor what happens, evaluate what the model is doing, and then decide, either maybe in an automated way, what to do from there. So the A/B testing, the upgrade, downgrade, the canary deployments, keeping track of even what's deployed, how it's performing, all that becomes part of the workflow stage. This becomes a key component that it's almost like the opposite end of the coin. We talked about the experiment tracker and the model store. On the other end, we need deployment and orchestrator that's keeping all this stuff working together. And finally, once the model's in production, we're not done. It's not like, okay, we've deployed, maybe we're running an A/B tests. We need something to monitor and evaluate them. It comes in 2 pieces. One piece is just capturing the logs, capturing what's happening, what's the model doing, making sure that that is stored somewhere, and that we have compute so that we can analyze what it's doing. That's great. That might be enough. But in practice, you're going to want some nice visualizations above that. You're going to want some nice maybe explainability, where it does some of the more traditional ways of checking, maybe like feature importance, alerting, catching things before they become problems. In production, things don't stay the same. They're constantly moving. It's kind of a fluid environment. And your model is, if trained well, should generalize well, and it shouldn't be an issue. But there's always going to be those like rogue waves where features drift really far, or something really strange starts to happen. And you want to catch that stuff before it creates a problem. I like to describe the stage, the tooling here, as being able to paint a picture of what's happening in production. That all comes together to build the components of the MLOps platform. Now, it feels kind of piecemeal, right? Like I showed you the data piece, the experiment piece, the model piece, the evaluation piece. There's this layer 4, which I call the platform layer. which kind of ties it all together. And this part, in my experience, tends to be the most custom piece per company. Um, there's all these artifacts that are created from version features and production training, version models, there's the deployments themselves, like the A/B testing, the canary, and then there's monitoring. So you're kind of creating different artifacts, both for the data artifacts and the model artifacts in the first two stages. The third stage is all about getting those into production, being able to A/B test them, do more complicated deployment. And then the final piece of this is just making sure it's behaving in production. This is one thing I saw, one example of a kind of Git workflow, which I thought was one good example. This is more focused on the data piece, the feature piece, where you'll develop your features, you'll do unit testing, you'll create a PR. Your PR will create your actual features and run and train your model on them and actually deploy that model for you to play around with. When it's merged, then the feature will actually go and get created. It'll get orchestrated. It'll get backfilled if it needs to be backfilled. And that becomes your production features that can then be used in the production setting. Another sample Git workflow is that data scientists work in the dev environment. Features and models must be registered in the feature store and model store. And then when you make a PR, when that PR is merged, they get tagged or they get moved into a different environment if there's different environments. They are moved into staging automatically. And when you kind of say the word, when they're being staged and you said the word, they move to production via canary test. So there's automated testing to A/B test your model in production and make sure that's behaving correctly. This is what the platform abstraction looks like. There's no correct way. I showed a few examples of how people tie it together. But I like to think of it this way. There are the engines, like I talked about, which are things like Dask, Spark, Redis, Seldon, like the kind of low-level engines, Kubernetes, that are needed to actually compute things, train things, deploy things. You need these subsystems for features, from like a feature store and experiment tracker, deployment, model evaluation, monitoring. Those fall under workflows. They focus on one piece of the model lifecycle, but they kind of, if you have all of them together, they don't necessarily naturally fit together. You need to find your own way of building a platform with these workflows, and that becomes the unified developer experience, which is the platform. There's a lot of different tooling for all these pieces. There are even tools like Kubeflow that work on the whole platform layer and kind of try to solve the entire problem. In each vertical, there are things like feature form, there's MLflow, and there's Seldon, there's Aporia and YLabs. There's a lot of different tools here. But the point of this presentation wasn't actually so much to show you all the tools, as much as to help you think about the workflows and the problems to be solved. And then you can look at the tools and figure out which one solves it best for your specific workflow. Now, you can deploy all this stuff. There's a lot of things you can do. I think one thing that's important is not try to do everything at once. Try to understand what problems you have the most. For example, if your problems are mostly around your data pipelines, getting those into production, making sure those work well, making sure the iteration on them is quickly, you might orient towards a feature store first. Maybe your problem, you're a computer vision company, and a lot of your problems are focused on evaluation. There's always your edge cases that keep breaking the model. How do you catch those things? How do you understand them? And how do you make your models more robust? Understanding those will help you decide where to invest first. And then the second piece is to start investing in metrics, understanding what's happening. There's different metrics. One metric or one flow is using door metrics. which are more typical DevOps metrics, which are how often are things being deployed, how long does it take to deploy, what's the lead time. If something goes wrong, can we revert? What does it take to revert? And how often do our newer deployments actually fail? All those things together, if you track these things, will help give you a good sense of how powerful your CI/CD is. It will also help you understand where to invest your time. If you have a lot of failures, you might be investing more in testing. If your problem becomes deployment frequency or lead time, you'd want to understand if it's data oriented or model oriented and then invest accordingly. Another way to think about this that I like is thinking of it from the team level, which is velocity, throughput, and risk. Velocity is how fast can an individual data scientist iterate and get something in production. Throughput is how cleanly can all the different stakeholders, all the different teams, all the different data scientists work together when needed. Is it easy for them to share things? Is it easy for people to do kind of like code review and the like? And then risks. Are there nice guardrails so that we don't kind of always have these risks of accidentally maybe it's using improper data, maybe it's putting them on production that's actually worse, or having feature pipelines in production that are incorrect or different from what we were trained on. How hard is it to do the wrong thing? That's another kind of dimension I like to think about. I'm also a huge proponent of treating your MLOps platform like a product. So there's kind of this metrics pyramid. The most lowest level pyramid is just the basics. Can I deploy my model? Is my model fast enough and can it handle enough load? If it can't, your infrastructure isn't there, then it doesn't matter. Like nothing else matters. That's like the number one priority. Once you know that you can deploy a model and it's ready for production, then the next problem becomes how fast can we iterate on those things? That becomes the second layer, which is a lot of what I just talked about. And then finally, there's the third layer. Once we know that our platform can enable high iteration speed, we know that we can deploy a single model. The final question becomes, how clean is this workflow for our data scientists? Does it feel natural to them? Do they like to use it? Some metrics here are going to be number of users, how often they're using it, like MAU, DAU. This becomes more product-oriented metrics. Awesome. So there's a lot of information. I hope that you can leave here today with a good sense of how, at least one opinion of how to think about CI/CD and MLOps, how to think about MLOps platforms, and how to measure those things. If you have any questions, feel free to throw them in the chat, and I'll try to answer them. If there's any on LinkedIn or Twitter, Marie here will also take a look. So I'll give a minute for people to put down any questions. And in the meantime, Marie, maybe you could share what people can expect with follow-ups and the like.
Absolutely. Thank you guys so much for attending our webinar. After this webinar, I'll send you guys a little follow-up email with links to our Slack community, links to our docs, and also this webinar recording. Also, if you guys have any feedback about our webinars or suggestions for future webinars, we'd love to hear that. You can reply to that email. Awesome. I don't see any questions on LinkedIn. So if there's any other questions, get them in now.
Yeah, I'll give it another second. If you have a question, maybe it comes up later, you can always throw them in our Slack community. You can always just email me directly. I'm simba@featureform.com. Yeah, so either way. Otherwise, give it one more second. If I don't see a question, then I'll give you back host Marie and you can send us off.
Alrighty. Have a great rest of your day, everyone.
Thanks.